Hello everyone, welcome back to Coding Charms. In this series, we are learning problem-solving pattern sliding window. In the previous lecture, we have already seen the introduction to sliding window. What are the things we have seen? We have seen what is sliding window and where should we use sliding window pattern and what are different sliding windows that exist. We have also solved a problem using sliding window pattern. This video is going to be an extension of the previous video. So if you haven't watched the previous video, I would highly recommend you to watch it first and then come back to this video. So let us quickly recap what we have done in the previous video. In the previous video, first we have seen what is sliding window. Sliding window is nothing but a continuous portion of an array or a linked list. When do we use sliding window pattern? If we want to find something in a continuous subarray or a sublist, we use sliding window pattern. And there are two types of sliding windows present. One is constant length sliding window and variable length sliding window. So based on the problem statement, we will use one of the sliding window techniques. Then we have taken a look at one example. Given an array, find the average of all continuous subarrays of the length k. We have seen an example. Then we have solved it using the brute force approach. In the brute force approach, what we are doing, we are going through all the arrays, then we are computing sum and we are dividing it by k to get the average. We are doing it for each and every array. Then we have the time complexity of the approach is O of n into k. Then we have seen there is a recomputation. There is a common part and we are recomputing the sum of this common part in both the every time. So there is a way to remove this recomputation to optimize. It is sliding window pattern. So we have solved the problem using sliding window pattern by removing the recomputation. Then we have that way we have reduced the time complexity from O of n into k to O of n. So I have found a similar problem to this in Geeks for Geeks. So let us solve that problem as well. So in the previous video, we have solved the problem, find the average of all continuous subarrays of size k. In today's video, we are going to be solving this problem, maximum average subarray. So in this problem, we are going to find, we are going to be given with an array of size n and a positive integer k. We have to find the subarray of length k with maximum average. So let's go through the examples. Here k equal to 4 and n equal to 6. The maximum average will be 51 divided by 4 for this subarray. And in the second example, we are given with k equal to 3 and n equal to 7. This array, the maximum average is 295 by 3, which will be for this subarray. So what is our task? Our task is to complete the function find maximum average, which takes an array of integers ARR and its size is n and an integer k input parameters and returns the integer denoting the starting index of the subarray. The time complexity should be O of n and the auxiliary space should be O of 1. So in the previous video, we have got the average of all continuous subarrays, but in this problem, we have to find the subarray of length k with maximum average. So let us copy this code. Let us see how we can use this code in our current problem. So this is why I said today's video is going to be the extension of the previous video. So make sure you watch that video before this so you can understand the sliding window concept that we are using in today's video. So here we don't need the result array. We can delete this and we have to calculate the maximum window sum. So let me initialize this with maximum window average and let us initialize this with the average is going to be double, right? So this should be double and let's say this is double current window average. And now we also have to have a with starting point so that we can return it as our result. And we have to check if current window average is greater than maximum window average. Then we have found a new a new window with maximum average. So window, we update the window start to be the current window starting point, and we update the maximum window average to be current window average. And finally, what should we return? We return window start. Let us compile it. It passes the sample test cases. Let us submit it. It passes all the test cases. So I hope you understood today's problem. If you did, make sure you like this video, and we are going to be solving more and more videos on sliding window pattern. So make sure you subscribe to the channel and turn on the bell notification button so you get notified whenever I post such useful content, and keep practicing. See you in my next video. Bye.